Hello everyone, and welcome again to this new lecture. And today we are going to do one problem or maximum two problem. We will try to cover it up. But because the first problem which I am going to do is the double pendulum, it is quite lengthy, and you have to be very careful about calculating the Lagrangian and the equation of motion of this double pendulum case. So without wasting time, let us try to calculate this double pendulum case. That is, so today's example is double pendulum. Okay. So as the name suggests, the double pendulum, we are going to have uh, the two pendulum attached to one another. So as a reference, so we have our x-axis here along this, and y-axis is going up. This is our reference point 0 0. This one is our 0 0, and this one pendulum is attached to this, and it is going to have its angle as theta 1, and the second pendulum is say this one, and it is going to have its say if we draw a parallel horizontal line with respect to which it is going to have its angle here. This is going to be theta 2. Okay, so and this is length L1 for the first pendulum, and this length L2 for the second pendulum. We talk about this mass of first bob is m1 and this is m2, and now we can have this coordinates. We can write the coordinates, because without writing coordinates we have to fix the reference frame, because when you are applying the potential energy, then you have to careful about it is minus or plus. So if this pendulum is going to have its coordinate x1 and y1, and this pendulum is going to have its coordinate x2 and y2. So first you need to write what is x1 y1 and what is x2 y2. So as you can see that my x1 is this. I hope this line is straight. So my x1 is this thing, and x1 is this, and y1 is this. And similarly for my x2 comprises of this x1, this whole x1, and plus this part. So this whole is my x2 is going to be, and then this one, this plus this y1. So this is going to be y1 plus this part. Say this is going to be L2 cos theta. So this is going to be L2 cos theta 2. Okay. So let's write this. My x1 is as you can see that x1 is here. This is L1. This is L1 cos theta 1. This is L1 and cos theta 1, and y1 is basically this height is going to be L1 okay, sorry, this is going to be L1 sin theta 1, because this length we are talking about, and this is y1 is L1 cos theta 1. Okay, so now we need x1 dot y1 dot also. So before that, let's write x2. X2 is, you know, so this contribution is x1. So x1 is my L1 sin theta 1, and this part with this is going to be L2 theta 2 plus L2 sin theta 2, and what y2 is consisting of, because y1 is, you say this is my y1 is with negative sign here, because I'm going down here from, this is my reference point. So this is going to be minus L1 cos theta 1 and minus L2 cos theta 2. So you have to be careful about writing L1 theta 1 because 4 things are going to change L1, L2, theta 1, theta 2, okay, in case of the double pendulum. Now I need for the kinetic energy, if you want to write the kinetic energy, so this is going to be half, and with this m1 with x1 dot square plus y1 dot square, and then you have to write for m2, this is going to be x2 dot square, and this is y2 dot square. So this is your kinetic energy. For that you have to find x1 dot, y1 dot, x2 dot and y2 dot. Okay, so let's try to find x1 dot is this one. X1 dot is this L1 L2 is constant, so it's not going to be differentiated. And then sine theta 1, this sine theta 1 is going to be cos theta 1 and theta 1 dot. Okay, and then this y1 dot is, you see, you have L1, and this cos theta 1 is going to be sine theta 1 with negative. So this negative part is going to be positive. So this is going to be sine theta 1 dot. Okay, and now for x2 dot, so because this is L1 sine theta 1, so this is going to be L1 cos theta 1 dot, and then with L2, so it's going to be L2 cos theta 2 dot. And then in the same way I can write this y2 dot is going to be, because cos, because with the minus sign, so it will become plus. So this is L1 sine theta 1 dot, and this becomes L2 sine theta 2 dot. So now you have x1 dot, x2 dot and y1 dot and y2 dot. So you can write your kinetic energy. T is like, first you calculate x1 dot square, y1 dot square. So this is x1 dot square plus y1 dot square. If you calculate for this, so this is going to be, you see, this is L1 cos theta 1 dot square. So this is L1 square cos square theta 1 dot square, and then this is y1, this is going to be L1 square sine square theta 1 dot square. Okay, so this is going to be because cos square theta 1 sine square theta 1 is going to be 1, so this is going to be L1 square theta 1 dot square. Okay, now for this x2 dot square plus y2 dot square is I have to take the square of this, the whole square of this. So this is a square plus b square. So if you say a square plus b square, so this is L1 square cos square theta 1 dot square, you can see, and then plus L2 square cos square theta 2 square theta dot square, and this is not there, this is theta dot square, and plus twice L1 L2 and theta 1 dot theta 2 dot cos theta 1 and cos theta 2. Okay, and plus this whole square of this thing. So this is a plus b, so this is L1 square, you have sine square theta 1 dot square, and plus L2 square sine square theta 2 dot square, and then you have twice L1 L2 theta 1 dot theta 2 dot, you have sine theta 1 and sine theta 2. So this you have x dot square plus y dot square. Okay, so now you can see here that this one is cos square theta 1 sine square theta 1 with the same coefficients L1 and L2. This is going to give you L1 square theta 1 dot square. Okay, so this x2 dot square plus y2 dot square is going to give you L1 square theta 1 dot square, and then what you have is similarly you have cos square theta 2 sin square theta 2 with the same L2 square theta 2 square and theta 2 square. So this is going to give you plus L2 square theta 2 square. So 4 terms we have already have, and then I can write these 2 terms. This is common, so this is going to be plus twice L1 L2 theta 1 dot theta 2 dot, it's common, and then what you have is cos theta 1 cos theta 2 plus sin theta 1 and sin theta 2, sin theta 1 and sin theta 2. So this is cos A cos B plus sin A sin B. So this is going to be cos A minus B cos theta 1 minus theta 2. So this x dot square is L1 square theta 1 dot square plus L2 square theta 2 dot square plus twice L1 L2 theta 1 dot theta 2 dot and cos theta 1 minus theta 2. Okay, so now I have my x1 dot square L2 dot square is this one, and x2 dot square and L2 dot square is this thing. So I can write the kinetic energy. Okay, so let's write kinetic energy, and here you can see one thing that I have m1 and m2. So you can I can go to this place. This is so kinetic energy. T is first is half m, that is x1 dot square and y1 dot square, and that is going to be L1 square theta 1 dot square. So this is going to be, this is m1 L1 square theta 1 dot square. Okay, and then for half m2 x2, so plus half, this is going to be m2, and what the terms are, this is L1 dot square theta 1 dot square, and with L2, and then L1 L2 cos theta 1 minus theta 2. So this is going to be L1 square theta 1 dot square plus L2 square theta 2 dot square plus twice L1 L2 theta 1 dot theta 2 dot and cos of theta 1 minus theta 2. Okay, so this is what you get. Okay, now you can see that this is this and this is same, so I can take it along one side. So this is going to be half m1 plus m2, that is L1 square theta 1 dot square, plus then half m2 L2 square theta dot square, and then I can have this will cancel out, so I just have m2 L1 L2 theta 1 dot and theta 2 dot, or with I have cos theta 1 minus theta 2. This is my kinetic energy. Okay, now what about the potential energy? So if you see, the potential energy is like the first one is for this potential, for this part the potential energy is going to be V1 is going to be minus m1g, and L1, this is L1 is this is basically y1, basically say this is y1, and this is going to be minus m1 g L1 cos theta 1 for potential energy, and then the second potential energy is going to be minus m2g, and because this minus is already I have not included in this y, so that's why this minus is there. So this is going to be y2. So this is going to be minus m2 g, and y2 is my the whole term. So this is going to be with L1 cos theta 1 plus L2 cos theta 2. Okay, so this is my the two potential energy corresponding to the two my pendulum. So I can write this V is here and T is here, so I can write the Lagrangian, and so Lagrangian is my T minus V is going to be half m1 plus m2 L1 square theta 1 dot square plus half m2 L2 square theta 2 dot square plus m2 L1 L2 theta 1 dot theta 2 dot cos of theta 1 minus theta 2, and the potential energy is plus, and this is m1g L1 cos theta 1 and plus m2g L1 cos theta 1 plus L2 cos theta 2. Okay, so this is what I have. So now I can, once I have the Lagrangian, so the two independent coordinates here are theta 1 and theta 2. I'm going to have two equations of motions. So this is so first equation of motion, the first Lagrange equation corresponding to theta 1 coordinate, theta 1 generalized coordinate. So you are going to have d dt of delta L by delta theta 1 dot minus delta L by delta theta 1 is going to be equal to 0. Okay. So I have to find delta L by delta theta 1. So this is delta L by delta theta 1. So if I concentrate here, so I have delta theta 1 here and delta theta 1 dot. I have to look for theta 1 dot. So theta 1 dot is here. So this is going to be m1 plus m2 L1 square theta 1 dot, okay, from here, and then from here this is going to be m2 L1 L2 theta 2 dot cos of theta 1 minus theta 2, okay, and I don't think nowhere else is theta 1. Now then I have to find delta L. So now let's find, first is going to be d dt of delta L upon delta theta 1 dot. So I have to find d dt of this thing, okay, d dt of this thing. So if you concentrate, the first term theta 1 is there, so this is going to be m1 plus m2, this is L1 square theta 1 double dot, okay. So this is theta 1 is only variable which is varying, so this is going to be affected by time derivative. Then in the second term, what I'm going to have, this one first is going to this one, this is m2 L1 L2, this is going to be theta 2 double dot and cos theta 1 minus theta 2, okay. Now the two terms are also going to come because I have this doing with respect to time. So theta 1 and theta 2 are also going to vary with respect to time. So two more terms are going to come. This is the first one is like when you do with respect to time, so this cos will become the minus sign. So this is going to be m2 L1 L2 theta 2 dot, concentrate here because I am doing this, and then you have sine theta 1 minus theta 2 theta 1 dot, okay. So because with respect to theta 1 here, and then the second term will come because of the theta 2, and that will be so because cos will be negative, but because of minus theta 2, that minus will become plus. So this is going to be half plus m1 L2, this is theta 2 dot will remain here, so you have sine theta 1 minus theta 2 and theta 2 dot, okay. So this is very important when you're taking the time derivative of this, because you have to consider each and every variable which can vary with time, okay. So now this is what theta 1, I think everything is there. Now I have to find this delta L by delta theta 1, okay. So now let's find delta L by delta theta 1. So this is going to be I must have a copy part, because so that I can okay, forget, so let's not. So now let us try to find this delta L by delta theta, this one delta theta 1. So this is going to be from here, from the Lagrangian itself. So this theta 1 is here, theta 1 is here, and theta 1 is here. So 3 terms are going to come here, contribute here. So from here this is going to be m2 L1 L2 theta 1 dot theta 2 dot, and because of the cos theta 1 is there, so it's going to be minus sine theta 1 minus theta 2. Okay, so and then the next term will be from here, this is going to be minus m1 g L1 sine theta 1, and from here this is going to be minus m2 g L1 sine theta 1. Okay, fine, this is okay, I think it's fine. So this is going to be minus m2 L1 L2 theta 1 dot theta 2 dot of sine with theta 1 minus theta 2, and minus m1g L1 sine theta 1 minus m2g L1 sine theta 1. So you can take m1 and m2 common here. So once I have this term and this term, I can write the Lagrangian. So let us write the Lagrangian here itself. This is so m1 plus m2 L1 squared theta 1 double dot. So this is going to be not here, m1 plus m2. So this is d dt of delta L by delta theta 1 dot minus delta L by delta theta 1 equal to 0. So I'm going to have this m1 m plus m2 L1 square theta 1 dot. This is going to be m1 plus m2 L1 square theta 1 dot square theta L1 square theta 1 double dot. Okay, L1 square, so theta 1 double dot, and m2 L1 L2 theta 2 double dot plus m2 L1 L2 theta 1 double dot, m2 L1 L2 theta 2 double dot, theta 2 double dot, and I have to concentrate here, cos theta 1 minus theta 2. This is going to be cos theta 1 minus theta 2, and then minus m2 L1 L2 theta 2 minus m2 L1 L2 theta 1 dot theta 2 dot, and sine theta 1 minus theta 2 is going to be sine theta 1 minus theta 2, and then plus m2 L1 L2 theta 2 dot square, and plus m2 L1 L2 theta 2 dot square. This is going to be sine theta 1 minus theta 2. Okay, this is one, and then you have to with the negative sign plus m2 L1 theta 1 theta 2, and this is going to be, this is for this kinetic energy part, and then minus m2 L1 L2, and then because this is minus here, and then this is minus will become plus, so you get plus L1 L2 theta 1 dot theta 2 dot sine theta 1 minus theta 2. This is my first term, and then m1 g L1 sine theta 1 plus m1 g L1 sine theta 1 plus m2g m2g L1 sine theta 1, m2g L1 sine theta 1 equal to 0. So now you can see here that one term is cancelling out. What is this? This one is, these two are cancelling out. So I've been left with these term. Okay, 1, 2, this 1, 2, 3 and 4 equal to 0. So I can write this as equation of motion is final equation of motion is say m1 plus m2 L1 square theta 1 double dot plus m2 L1 L2 theta 2 double dot, and then you have cos theta 1 minus theta 2. This is and then the two more term are here. This is going to be m1 g L1 sin theta 1, and then you have m2 g L1 sin theta 1 equal to 0, because m2 and L1 is there, m2 and m2 is there. So you can combine this m1 plus m2. So you can combine this here, that is going to be or I can write this is have to better look, and this L1 square theta 1 double dot plus m2 L1 L2 theta 2. What is the square term? Okay, I've left this term here. This term is to be there. This one 5 term is there, m2 L1 L2 theta 2 dot square, and then I have sine theta 1 minus theta 2 equal to 0. So L1 L2 theta 2 dot, you have cos theta 1 minus theta 2 plus you have m2 L1 L2 theta 2 dot square, and you have sine theta 1 minus theta 2, and plus I can write this m1 plus m2, these two terms GL1, this is going to be sine theta 1 is equal to 0. So this is the equation of motion corresponding to the theta 1. Okay, so if you apply the small angle for a small angle, or for a small angle approximation, so this is this cos theta 1 minus theta 2 is going to be 1. So you have cos theta is 1, and you have sine theta is theta, okay, in a small angle approximation. So from here this becomes m1 plus m2 L1 square theta 1 double dot plus this cos theta will be 1. So you have m2 L1 L2 theta 2 double dot, and then this third term, because here you have square of theta 2 and you are supposing a small angle, so this is going to be more smaller. So I can neglect this term altogether from here. I can neglect this whole term here from here, because under a small angle, and then I have this m1 plus m2 gl1, because sine theta is, this is theta 1 equal to 0. Okay. So now you can see that if in this equation I just have to look that yes, I got the same equation, fine. So theta 2 double dot, fine. So this is after a small angle approximation, and you see that this is complicated, not complicated, but you have to be very careful about theta 1, theta 2, L1 and L2. So now if theta 2 is if you fix the moment that theta 2 is not theta 2 dot is 0, so then what you have this equation of motion of the simple pendulum. Okay, so for if you say theta 2 dot is 0, so then this part is not there, this part is not there, and you have theta 1 dot and theta 2. So you are going to have the same equation of motion, because you are going to have this m1 plus m2 L1 square theta 1 double dot plus m1 plus m2 gl1 theta 1 equal to 0. So if you get rid of this mass because it's 0, so you have theta 1 double dot plus g by l1 theta 1 equal to 0. Okay, so in the same way you can calculate for angle theta 2 and theta 2 for equations of motion. So you have to be careful about this. So I think in the next class I'll move further from here, that we will try to find out the equation of motion for theta 2. So we had to remember, so I'll start from the already calculated Lagrangian in the next class, so I don't have to calculate all those things. Okay, so we'll quickly do calculate the theta 2 equation of motion, and then do 1 or 2 more problems. So I I stop this at this level, and thank you very much. We'll meet in the next class. Thank you.